Now we're going to go over vertical stretching and shrinking of a graph. So last time we start for this section, we talk about shifting, shift to the right, shift to the left, up and down. And also reflect around the x-axis or around the y-axis. So today we're going to start the vertical and the horizontal stretching and shrinking for the graphs. I will start for vertical. Stretching. And shrinking of graph. Yeah, so the vertical stretching and shrinking of the graphs. So let me give you the definition, then I will explain the definition. So to graph the function y equal c times f of x, c is a number, any real number, c. We multiply by the function f of x. So to graph this function, we're going to check first of all the value for c. If c is greater than 1, like 2, 3, 4, 5, up to infinity, what we do, we graph the original function, y equal f of x, then we stretch the original function vertically by the factor of c. So we stretch the graph for the original function f of x vertically by the factor of c, by this number c. If this c here is between 0 and 1, like example 1/2, 1/3, 1/4, 1/5, any number between 0 and 1, then the graph for this function, this one, is the graph for the function y equal f of x, but we shrink this function vertically, okay? So let me explain more for these things. So let me graph a function. Let me explain that by the graphing. So let me do the graph the Cartesian plane. This is the Cartesian plane. So now suppose my original function is the black one, goes up to here, then stop here. From this side is like this. This is my original function. This is f of x. This is x-axis, and here's the y-axis. Y-axis. Now, suppose I want to graph the function by using the red color, f of x equal c times f of, not c, here, the graph is not f of x. Suppose I want to graph the function y equal c times f of x. And this c is greater than 1, like 2, 3, 4, 5, whatever. Like here, I put condition c is greater than 1. So the graph for this function is stretching of the original function. This is the original, the black one, vertically. Okay. So this is mean stretch this function vertically. This point will stay on the x-axis, and we stretch this function upward like this, vertically, and this is vertically. Okay, means the function, the new function, it's going to be something like that. This is vertically. So this is the red one, is the function c f of x, and here again c is greater than 1. Okay, now if I want to graph the function, for example, y equal c times, look, see here outside the function f of x, and the c here is between 0 and 1. Suppose c is between 0 and 1. Between 0 and 1, like 1/2, 1/3, whatever, like less than 1, greater than 0. So this is mean we shrink the graph of the original function vertically. Shrinking means we shrink to the x-axis. We shrink this curve, the black one, close to the x-axis. This is mean shrinking. So the new graph, it will be like that, vertically, like this, here, like this. So the blue one is the graph the blue color, and this is blue, so it will be like something like that here, and something like that here. So this, the function here is f c times f of x, c times f of x, such that c between 0 and 1. Any question for this one? Is it clear? What's the mean of shrinking and what is the mean of stretching? Okay, now let's go to the horizontal one. This is the vertical. Okay, now let's go to the horizontal. Okay. So now horizontal stretching and shrinking of graph. Okay, so the definition now, it is similar but not exactly the same. It is similar only, it's not exactly same definition. I mean, definition will be as this. Okay, let me read the definition. So now, if I want to graph the function y equal f of c times x, look the c, where is it? It's inside the function. The c here is it's inside the function. Let me use the green one. Okay. The c is a real number. It's inside the function. So if c between 0 and 1, we do stretching for the graph, for the original graph, but horizontally. Why horizontally? Because the c, it's inside the function. And what we do, stretching, opposite to the first one. Here, shrinking, if c between 0 and 1. But here, if c between 0 and 1, we do stretching, not shrinking. For the second one, if c is greater than 1, like 2, 3, 4, 5, we do shrinking, opposite to the first one. There, we do stretching for the original function. And how we do it? Horizontally. Why? Because the c, it is inside the function. Now, let me explain that by the graph. So suppose my graph like this. So my original graph is the black one. X-axis. Y-axis. Again, this is the graph for the original function f of x. Now we want to graph the function y equal f times cx, and c here is between 0 and 1. C is between 0 and 1. So we do stretching for the graph horizontally. Horizontally means like this. This is horizontally, okay? This is mean horizontally. We do stretching horizontally. So let me do the stretching horizontally like this, like this. This point will be the remain, the same point. Stretching horizontally, the function will be stretched like this. And here, other side will be like this. This is the function y equal f of x, f of c times x. And here c is between 0 and 1. Okay. This side horizontally, this side horizontally. Here vertically again, like up and down. Now for the other function, y equal f times cx, and c here is greater than 1. This means we do shrinking for the function horizontally. This is the x-axis. This is point still remain. Shrinking, this means we shrink the function horizontally. So the point here will go to here. So the point will be like the graph look like this. Like we shrink the function. Something like that. Here the blue one is y equal f times cx, and c is greater than 1. This is the mean of the shrinking. Any questions so far? Is it clear? Okay, now let me give you an example, like normal example. The question is using the graph example, using the graph OX equal x squared to sketch each of the functions. Number 1, g of x equal 3x squared. Number 2, h of x equal 1 over 3x squared. Okay, I need to think about the first one, and I need tell me it's vertically shrinking or stretching, or is horizontally stretching or shrinking. For the first one, A. Who will do the first one? G of x. Who will do the first one? G of x.
It's stretching vertically, right?
It's stretching vertically. Okay, this is it's true. How you think about this question? Like that.
Because the x squared is the function. Like if it was 3 times x squared, I have 3 plus x squared inside of parentheses would be different.
Nice. This is true. So the original function here, OX, is equal x squared. So my original function OX equal x squared. To make this function is equal to the function g of x, we multiply both sides by 3. We multiply from outside times 3 times 3. I get 3 OX equal 3x squared. This is mean the 3 it's outside the function, it is not inside the function, and this is equal g of x. So to graph this function g of x, we have to graph the original one of O of x. Then we have to multiply by 3. The 3 here is outside the function. So 3 times O of OX, the original function is x squared here. This is mean the 3 is outside, so we're going back. Here the numbers is outside. To graph this function, it's outside. Now we check the C to know is stretching or shrinking. So the C here is greater than 1, 3. 3 is greater than 1. This is mean we do stretching for the graph, for the original one. Okay, let me do it. So again, this is outside, the number here outside, and 3 is greater than 1. 3 outside mean vertically, and 3 is greater than 1 by going back. This mean stretching. So we graph the original one. The original function is OX equal x squared, and by using the graph from last time, the OX equal x squared will be graphed like this, parabola. So OX equal x squared. This is the original function. Now, to graph this function, we have to do vertically and stretching for the original function. Vertically means like that, something like that, or something like that. This is vertically. And the stretching means all points going up, but the 0 still remain. So the 0 still remain. Here's 0. This point here, 1 and 1, 1 and 1 goes up like around here. This here, this point goes up. So this is mean stretching vertically will be like that. The graph like that, something like that. And here from this side, the same things, something like that. So this is the graph for the function g of x equal 3x squared. So again, to graph this function, we graph the original one. We graph the original one, the red one. Then by using the rules from before, the number is outside the function. Now we check the number. Is it greater than 1 or between 0 and 1? The number is 3, is it greater than 1? This is mean we have to do stretching for the original function. So this is the original function, the red one. We do stretching. So the graph is the blue one. This is g of x, this is O of x, the original function. Okay. Now for the second one, who will do the second one? Who will do number B? Or tell me which rule I have to use from the previous rules. Which one I have to use? Is it horizontally or vertically? And Which kind of vertically? Stretching or shrinking? Same things for the horizontally. For B. What is the answer for B? First of all, look to the number. Is 1 over 3. It's outside or inside the function? It's outside, yes. Second question, 1 over 3 is greater than 1 or between 0 and 1? Is between 0 and 1. So we go back to the rules. If the number is outside and this number is between 0 and 1, we have to do shrinking for the graph vertically. Shrinking for the graph vertically. So this is my original function, the red one. We do shrinking for this one. Shrinking means we push it down vertically like this. We push the function down. So the 0 keeps 0. 1 and 1 will be like this, 1 over 3. The function look like that. So the graph for B, the function B here, for B, h of x equal 1 over 3 x squared. So 1 over 3, it's outside, and 1 over 3 is between 1 and 0. Okay? Outside mean vertically. And here, between 0 and 1 means shrinking. So the graph, it's like the yellow one. This is shrinking and vertically. F of h of x equal 1 over 3 x squared. Any question? Anyone has a question for this one? Okay. Let me give you another example. From before we did A and B, now C and D. C is d of x equal 2 times x squared, and D is, no, that's it, just C. Who will give me the idea how we can graph this function? I need the idea how to graph this function, C.
It's going to be like x squared, but shrunk horizontally.
This is true. This is True, it's like x squared, but we have to know it's the number, it's inside or outside. So the 2 here, it's inside the function or outside the function?
Inside.
Inside the function. So the number is inside the function. This is mean, go back, inside the function horizontally. Horizontal. Now we'll go back again, check. Is the number greater than 1 or between 0 and 1?
Greater than 1.
Is it greater than 1? Go back again. Greater than 1 means shrinking the graph of y equal f of x horizontally. Shrinking means like the blue curve. This is the original one. The black is the original function. The blue is shrinking. Okay, let's graph this one. I know the original function is x squared. So graph the x squared. So the graph looks like x squared. Is the x squared. This is O of x equal x squared. The 2 it's inside and 2 is greater than 1. Inside mean horizontal, greater than 1 mean shrink. So now we're going back to the Cartesian plane to graph a function horizontally, something like that, or something like that, horizontally, and shrinking. So like this. This is shrinking. Shrinking going close to the y-axis. So this is the graph for t of x equal to x squared. Any question how to graph this function? So the red one is 2x everything squared. The black one is the original function, x squared. Okay, now let's go to the even and odd function. So again, this is x-axis here, x-axis, and y-axis. Even and odd function. So let me give you the definition for even and odd function. Let f be a function. This function to check is even or odd by using the rules says f is even function if f of x equal f of minus x. For all x in the domain. For all x in the domain. For the second one, f is odd function if f of minus x equal f minus f of x for all x in the domain. Okay. Okay, so let me give you an example for this one. Okay, example. Determine which of the function is even or odd. So the first one is f of x equal x cubed plus x, b g of x equal 1 minus x squared, c del of x equal 2x minus x squared. So to check the function is even, we have to check this condition, f of x equal f of minus x. To check the function is odd, we have to check this condition. If the function is not even, is not odd, is not satisfy one of the first one and the second one. So even or odd or neither even nor odd. Okay, so I have to check the function is even or is odd or not even, not odd. For the first one, here, how can I check is even or odd? The first function.
Just by seeing the exponent. Yeah. Just by seeing the exponent.
Exponent?
Yes. If the
no, we're not looking for the exponent for this. For this questions, we're not looking for the exponent. If it's odd exponent, so it's odd function. This is wrong. We're not looking for the exponent for the function. If it's has odd, and this has odd, it does not mean this function is odd function. But maybe it is odd, but we have to check these conditions. Condition says we have to check is f of x equal f of minus x, is f of minus x equal minus f of x. So let me explain more how we can do this one. So my function is f of x equal x cubed plus x. So we have to write the f of x and f of minus x and minus f of x. And we check, is f of x equal f of minus x, or f of minus x is equal to minus f of x, or neither even, neither or, nor odd. So first one here, f of x, my function is, we keep it like this, x cubed plus x. F of minus x, we plug the minus inside the function. So I get minus x cubed plus minus x. Here we multiply the minus to all the function. So they give me minus times x cubed plus x. Now we have to simplify these things because we have to check which one is equal to the other. So here the function is simplified already, x cubed, we keep it the same things, x cubed plus x. For the second one here, minus x cubed, we give me minus x cubed because minus times minus times minus, they give minus. Here we have plus times minus is minus x. For the third one, we have to distribute the minus inside the parentheses. So this is giving me a minus x cubed minus x. Now we have to check mean. We have to ask ourselves, is f of x equal f of minus x? Is this things here equal to these things?
No.
No. Look, x cubed plus x, and here we have minus x cubed minus x. So the answer is no. So it is not even. Because the function will be even if f of x equal to f of minus x. So this is mean f of x not equal to f of minus x. So no, it's not even function. Now we have to check the second condition. Is f of minus x equal to minus f of x? Go here, back here, we see minus x cubed minus x. Here we have minus x cubed minus x. Both of this and this are equal. So the answer is yes. Look here, this function is exactly like this function. So the answer is yes. So this means the function is odd. Is odd. Any question for this one, for the first example? Okay, for the second example, who will do the second one? G of x equal, second one is like this, b g of x equal 1 minus x squared. Is even or is odd or is not even, not odd? So what is g of x?
It's even.
Is even. How you know? You do the same steps here. You did the same steps. So he said is even.
If you substitute negative x squared,
Yes, what is the negative x when you substitute? 1 minus what? Square. 1 minus x squared is x squared. And we have to do the third one is minus times f of x. So minus times g of x. This means minus times the original one, 1 minus x squared. And they give me, they distribute the minus inside the parentheses. Give me minus 1 minus times minus is positive x squared. Now we have to check which of these three are equal. G of x is equal 1 minus x squared is equal to this one. So my question now is g of x equal to g of minus x? Look to the g of x, 1 minus x, and g of minus x is 1 minus x. This function and this function are equal. So g of x equal minus g of minus x. So the answer is yes. And this is mean from backing here, f of x equal f of minus x, the f is even. So mean here, the function is even. We don't have to check for odd for the second condition because the function is satisfied to be even. So done. For the third one, who will do the third one? C. So the function is even, C. C. Function is h of x equal to x minus x squared. Is even, odd, not even, not odd. Who will do this one? Same like before. This is h of x. Now we check h minus x. Then you check minus times h of x. So when you plug the minus x inside the original function, I get 2 times minus x minus x squared. What does that give me here? 2 times what? Minus x is minus 2x minus x, everything squared is x squared. For this one, we multiply the minus for all function. This is the original function. 2x minus x squared. We distribute the minus inside the parentheses. Get minus 2x plus x squared. Now we have to check, is this function is equal to this one? Or this one is equal to this one? So you said is h of x equal to h of minus x? Look to this function and this function. This function not equal to this one. So the answer is no. This means the function not odd, the function not even. Now, second question is h of minus x equal to minus h of x is this function here equal to this one? We have here minus 2x minus x squared. We have here minus 2x plus x squared. So the answer also no. The function not odd. So the function is not even, not odd. This means the function is neither. Okay. So neither even nor odd. Okay. Any question for these things? Is it clear how to check the function is even or odd? If you have questions for this, you can ask me. Okay, now let's go to 2.7 if there is no questions. 2.7 is combining function. So sum difference product and quotient. So first of all, we're going to talk about how we can do sum for any two function, the difference between any two function, the product between any two function, and the quotient, fraction between any two function. So suppose I have two functions. The first function is f, and I have the second function is g. So both of them are function defined on domain. The function with domains A and B. So then the function, I'm going to define the sum, then the functions f plus g, comma, f minus g, and fg, f over g are defined as the following. So f plus g so here f plus g for the function x is equal f of x plus g of x. Here the domain would be the intersect between the both domain for the first two functions. So the domain for the function f is A, the domain for the second function g is B. So the domain for the sum of the two functions are the intersection between the both domain, okay? So the sum between two functions is defined as the first function plus the second function. Now, the second, now the difference, f minus g times x is defined as the first function minus second function. The domain again is the intersection between the both domain, A intersect B. Now f times g of x, what is that equal? Same like here, f of x times g of x. The domain again is the intersection, A intersect of B. This is the product. Now the last one is the quotient. How we can define the quotient? So the quotient is f over g for x is equal the first function of x over g of x. So this is the quotient here. But the domain is different. The domain here A cos B except the zeros for g of x. Why? Because we have to remove the zeros from g of x for the denominator to make the function here defined. Okay, let me give example for this. I can't scroll down. Okay, what does that mean? This means here the intersection between the first domain and the second domain. I'm going to explain more during the example how to find the intersection between both domains. The only for the division, the domain is A intersect B, and we have to remove the zeros for, like the domain is A intersect B, and also we have to remove the zero for the denominator for this fraction, or the zeros for g of x. Okay. Let f of x equal 1 over x plus 2 and g of x equal square root of x. First question is find the function f plus g of x, f minus g of x fg x and f quotient g of x and their domains and their domains. Second example is, we'll do it later. Okay, what is f plus g for the first one? Here. So by using the formula here, f plus g of x equal f of x plus g of x separate. So the formula here, f plus g of for x is equal the first one plus the second one. So the first function is 1 over x plus 2. So this equal here 1 over x plus 2. And the second function g of x is square root of x plus square root of x. This is f plus g of x. We keep it like this. We don't have to simplify it more. Now, what's the domain for this function? So to find the domain for these things here, for all this, to find the domain, we have to find the domain for the first one, to find the domain for the second one, and the intersection between the both of the domains. So, what is the domain for 1 over x plus 2? What is the domain for this function?
All real numbers except -2.
Yes. So the domain for this one is r minus 2. I graph the real line. I'm going to graph the real line to show you how to find the intersect. So this is the real line for first function. So all real numbers except 2. At 2 here, this is 2 here, is open circle. So here's 2, and everything is in the domain. At 2 is open circle here. It's not inside the domain, and everything is inside the domain.
Shouldn't be -2.
-2, sorry, is -2 here. Here, -2. So I'll move this point up to here, like make it here. This is -2. And here I close it. Remove. Remove. So all numbers except -2. So this real numbers except this point at -2. Now the domain for the second function. What is the domain for this function? What I can plug here?
All real numbers or positive numbers.
And 0, yeah.
And the 0, right? Here I get the question, can you just set them equal to each other to find the intersection? No, this is wrong. So I'm going to show you how to find the intersection. By this step, you can find the intersection. So here, the domain for the first function is all the numbers except the 2, minus 2. And the domain for this one is all the number from 0 to infinity. So you have to draw a real line again. This is the real line. At 0, this is minus 2, the 0 will be like around here. Is inside the interval. And all numbers greater than 0. Now, to find the domain for the function, the sum function, this one, the domain for f plus g x, we draw a real line. Here's the real line. And you find the intersection between the both real lines above. So the intersection here, all this number are not used. All this number are not used in this function. So there is no intersection between this line from the 0 to minus infinity. No intersection between these 2 points, 2 lines. At 0, there is intersection between these 2 lines. The 0 are used for both line. So the 0 are used for both line. This is mean we start from 0. So this is 0. Now, after the 0, everything is used. After the 0, everything is used. This means everything here will be in the domain for intersection. So the domain is from 0 to infinity. This is the intersection from 0 to infinity. It makes sense now how to find the domain, how to find the intersection between the both domains. Draw a line for the first function, line for the second one. You see the intersection between the both line. The intersection between the both lines start from the 0. 0 is used for both line, and any number is greater than 0 is used. They are intersect. For any number less than 0 here is used for this line, but except the minus 2, but here it doesn't use at all. So this is not intersect with this one. So the domain will be the intersect from 0 to infinity. The 0 it's inside because they intersect at 0. Any question for this one? Okay, for the second one, second example, f minus g of x. Here, f minus g of x. F minus g of x. So by using the rules here, f minus g equal f, the first function minus the second function, the domain is the same like the sum. So the domain here is the same like this, the domain that we found it. So f of minus x of x equal f of x minus g of x. And this is equal, f of x is given 1 over x plus 2 minus square root of x. The domain is the same as before. Domain is from 0 to infinity, like a sum, exactly like the sum. Third one, who will do the third one? F times g of x. What is that equal? What is that equal here?
F of x times g of x?
Yes, nice. So this is equal f of x times g of x. F of x is given here is 1 over x plus 2 times g of x is square root of x. So the multiplication is simple here. The domain times the domain, the numerator times the numerators, and the denominator times the denominator. Actually, this function is over 1. So 1 times square root of x is square root of x, and 1 times this thing is x plus 2. What is the domain? So the domain is the same as the first one and second one, the intersect. Now for the last one, quotient. Now for the quotient. F over g x. What is that equal? F of x over g of x. So again, what is f of x? From back, f of x, this function, 1 over x plus 2. So 1 over x plus 2. By the way, let me remind you, f of x over g of x is equal f of x times 1 over g of x. So now f of x is the same thing like this. We multiply by g of x, we multiply by the reciprocal of the second function. So the function g of x is square root of x, is the square root of x. We multiply by the reciprocal for square root of x is 1 over square root of x. Now we have multiplication between two functions, numerator times numerator, denominator times denominator. So they give me 1 over square root of x times x plus 2. Now, what's the domain?
It's the same, right?
Is the same, but we have to remove is the same, but we have to remove the zeros for the function g of x. Like is the intersection between the both domains, but we have to remove the zeros for the second function g of x. So what is the zeros for the function g of x?
0.
Is 0. So the domain is the intersection A cross intersect B, except the zeros for square root of x. The zeros for square root of x is 0. The domain and A intersect B is the closed interval from 0 to infinity. So we have to remove the 0. So the domain for f g for x is open interval from 0 to infinity. We have to remove the 0 from the intersection. And this is the solution. Any question? Okay. If you have a question, you can ask. Now the second example is the same like this one. Here, evaluate. This is B. This is here A. B says find f plus g for 4, f minus g for 4, f g for number 4, and f quotient g for the number 4. We'll do the first one. What is that equal here? So this is equal by using the formula f plus g for x is f of x plus g of x. We are applying this for 4. So f of 4 plus g of 4. Now you plug the 4 inside the function. Write it down here, the function f of x equal 1 over x plus 2, g of x equals square root. So f of 4, you plug the 4 inside the function here, get 1 over 4 plus 2 plus g of 4, you plug the 4 inside the function g, get square root of 4. And this is equal 1 over 6 plus square root of 4. Square root of 4 is 2. And this is equal 12 plus 13 over 6. we do cross multiply. Actually, this is over 1. Cross multiply. The 2 times 6 is 12. 1 plus 1. 1 times 1 is 1. 12 plus 1 is 13 over 6. This is a review from the first chapter. Now for the second one, f minus g for x for 4. You're applying the same formula, minus g of 4. Who will do this one? What is f of 4? It's like before. 1 over 4 plus 2 is 6. 1 over 6. Minus g of 4, square root of 4 is 2. Now we do the cross multiply. 6 times minus 2 is minus 12, plus 1 minus 11 over 6. Let me explain more here. So 6 times minus 2 plus 1 over 6 times 1 minus 12 plus 1 over 6. Give me minus 11 over 6. Any question for this first one and second one? Now for multiplication. Fg times x times 4. Same things, f of 4 times g of 4. You plug the 4 inside the first function, give me 1 over 6 times the second function 2. Can simplify 6 with the 3. With the 2, they give me 1 over 3. For the last one, the quotient of quotient f over g to the 4. Give me f of 4 over g of 4. F of 4 times 1 over g of 4. F of 4 is 1 over 6, like before, times g of 4 is 1 over 2. We multiply 1 over 12. Any questions so far? Okay, if there is no question, we're going to stop up to here today. Thank you.